Hello everyone, it's Mrs. Hogan here. I'm so sorry I'm not in class today. I had another appointment I needed to go to, but for our new material today, I think it would be best if I made a video instead of you guys reading the notes online, just because it's a lot of information and it's just easier if it's easier for you to understand it if I explain it through a video instead of you reading off the PowerPoint. But anyway, welcome to a brand new semester, second semester. We are learning about quadratics. So we've learned about shapes, geometry, and now we're moving on to Algebra 2, okay? So we're going to be moving on into learning about quadratics, which you guys are pretty much familiar with from junior high, but we're just going to deep dive in, learn some new material today, okay? Well, first, we're going to learn some new material. Okay, so features, we're just going to be talking about features of a quadratic function. Okay, and so what makes a quadratic function is that if you look at the top here, okay, we have three different forms of a quadratic function. And what makes an equation a quadratic is that the greatest term, the term has a power of 2. Okay, so these have a power of 2. And then eventually a factored form, it will have a power of 2 when you multiply all the terms together. Okay, but we'll talk about that more. Okay, so what we're going to be focusing on is looking at a quadratic function in standard form. Okay, so y equals ax squared plus bx plus c. Okay. So, all right, so let's go into learning about parts of a quadratic function. Okay, so we're going to be looking at number 1, okay, in your notes. The graph of the function y equals 2x squared minus 8x is shown. Use the graph to identify and define each attribute listed. All right, so let's start to the left over here. Okay, so x-intercepts. Okay, which you guys are familiar with. X-intercepts are where the function crosses the x-axis, okay, and we represent it as a point. So x comma 0. So here, looking at this graph, okay, my x-intercepts are points where the function crosses the x-axis. Okay, so my x-axis is this guy right here. Okay, so it looks like it crosses it twice. Okay, so first one right here at 0, 0, and at 4, 0. Okay, so it crosses it once. So those are my x-intercepts. Okay, crosses it just twice. And then my y-intercept is where the function crosses the y-axis. Okay, so my y-axis, it's the vertical axis right here, and it looks like it crosses it just once. Okay, just one time. So here at 0, 0. All right. Okay. So those are x and y intercepts. The next one is called a vertex. So when you're asked to find the vertex of a graph, it's the maximum or the minimum point of the function. Okay. So it's the most maximum points and the most minimum. So here, looking at my graph, okay, I have a minimum point, okay, because it's right here at the bottom, okay. I do not have a maximum because if you see, okay, this point, it creates this parabola, or this graph, and it goes on and on and on forever at the top, okay. So this one has a minimum point, okay, when we just got to identify this point, which is 2, -8, right? Okay, so another thing about a vertex, okay, if the parabola opens up, okay, like this guy, I have a minimum point right here, okay, this is a minimum. But a maximum is when it opens down, my graph opens down, and I have a maximum point right here at the top. Okay, so that's pretty easy to identify a vertex in your graph, okay, if it's a minimum or a maximum. And then concavity, okay, switching my colors here. So concavity, okay, this is probably the easiest one, okay? It's the direction the graph opens. Does it open up or does it open down, okay? So this graph right here, he opens up, okay, and then that's it. So when you're asked to find concavity, you're going to say, oh, it opens up. Okay, opens up, not ups. All right, and then that's it. Okay, that's my answer. There's concavity. Does it open up or does it open down? If it opens down, okay, it's going to look like this guy right here. All right, in your notes. All right. Okay, next part is a stretch. Okay, so when you're looking at a stretch, okay, stretch on your graph, it's the pattern of how the parabola moves from the vertex in relation to the normal stretch. All right, okay, so pay attention to this one, okay, because it can be a little confusing. So that means from the vertex right here, okay, it's how much it stretches. So you'll see that every time you look at the vertex, you're always going to go over 1, okay? But that's not what my stretch is. The stretch is how much it goes up and then how much it goes down from here, okay, to your next point. So then from here, do you see that to find the next point on the graph, you go up 1, 2 on both sides. 1, 2. Okay, so it goes up 2. That is my stretch. Okay, it goes up 2. You go over 1 and up 2. An easier way to tell what this is that if you're given a function of a graph, so look, if you look right up here, so y equals 2x squared minus 8x, do you see that your a value is also 2? That's another way to easily tell what your stretch is going to be. Okay, a is just your 2. Okay, so that's how much it stretches, right? All right, okay, so that's my stretch. And then the axis of symmetry, okay, right, okay, my axis of symmetry, the line of the symmetry of the parabola x equals blank, okay? So an easier way to tell where the axis of symmetry is, it's where your graph is cut in half. Your graph is cut in half. Okay, so for example, if I have a graph right here, okay, that opens up, where the graph cuts in half is right here. Okay, we cut in half and it's symmetrical, okay, because when you fold it in half, the lines align to each other. Okay, so that is my line of symmetry. It's where you cut your graph perfectly in half. So like this one right here, and it's usually where your vertex is. Okay, your vertex is 2, -8. That is where your line of symmetry is. So it cuts the graph in half right here. Okay, and we always write it as an equation. So x equals, you see where it crosses here on the x-axis at 2. Okay, so here x equals 2. Okay, and it's always going to be your x value. It's never going to be your y, because that's where your graph crosses on the x-axis always. Okay, and it's usually the x value of your vertex. Okay, all right. Okay, last two. This one is called a domain. Okay, so domain, this is new. Okay, so pay attention to this part. Okay, so your domain is all possible x values of your function. Okay, so when you're looking at the x values that your function could possibly hit, okay, we read it from looking at the graph from left to my right. Okay, left to your right. Okay, and we write your domain in interval or inequality notation. Okay, so interval notation. So what that means, if you're looking at it from the left, so let's look at my graph from the left. Okay, so from the left of the x-axis, do you see how it's going on and on and on forever? Okay, toward all of your negative x values. It's going to hit all of your negative x values, and it's going to go on for infinity. Okay, so then from the left, it's coming from negative infinity, okay, And then when you move on to the right, okay, moving on and on to the right, if you look up here, that goes on and on to infinity as well, okay, hitting all of your positive x values. So if it's hitting all of your positive x values, that's going toward positive infinity. So here is my interval notation, okay. And in a quadratic equation, your interval is always going to be this guy, okay? It's always going to be negative infinity to positive infinity, okay? So you can never go wrong there, okay? But then your range, okay, your range are all possible y values of the function, all positive y values that your graph is going to hit, okay? And we read that from we read the range looking at the bottom of the graph, the bottom all the way up to my top, okay? How much is my graph going to cover? But then you see from the bottom, it starts right here on my y-axis. It starts right here, okay? And it starts right here at -8. So when I write that interval notation, so bottom to the top, okay, it starts at -8. And then, okay, when you go up to the top, so looking up, it's going on and on and on forever, okay, toward all of your positive y values. So that's going toward positive infinity, okay. But then here's the catch, okay. You always use the -8. If that's where it starts, we always use a bracket, okay. We use a bracket to where it starts. I use parentheses here, okay, because it never stops. Infinity never stops. It goes on and on and on forever, okay? But I use a bracket to show that it definitely starts or stops at this number, okay? So this is my correct notation for this guy. All right? Okay, so those are all of our parts of features of a function, okay? So now let's go over an example, okay, in your notes. Let's go over number 2. So number 2, the graph of the function y equals -1/2 x squared, -x plus 4 is shown. Use the graph to identify and define each attribute, okay? All right. Okay, so let's start with x-intercepts. Okay, x-intercepts where the function crosses the x-axis. Okay, so the x-axis again is right here. So it crosses it twice. Okay, and then listing those points. It's -4, 0, and 2, 0. Right, so those are my x-intercepts. My y-intercept, okay, where the graph crosses the y-axis, crosses it just once right here, which is 0, +4. Okay. Awesome. All right. Okay, vertex. Okay, so remember, the vertex is where is the minimum or the maximum of your graph. Okay? So if you look at this graph, it opens down. Okay, my graph opens down, which means that it has a maximum. Okay, maximum point right up here at the top. Okay? So then the maximum where my graph starts looks like it's right there. Okay, and then that point is, so -1 for x and 4.5 for y. Okay, looks like it's right in between 4 and 5. Okay, all right. So that's my vertex. Concavity, how does my parabola, my graph open up? Does it open up or does it open down? It opens down. All right, okay, pretty good so far. All right, so about my stretch, okay, so remember your stretch, how much does it open? So you can look at the a value of your function here. So my a value is -1/2. Okay, so a is -1/2. But let's just double check on the graph right here, okay? So looking at my vertex, okay, so we go over 1 on both sides. And then how much do I go down to my next point? So it looks like I go down just halfway. Okay, and then you recognize that it goes down which means that it's definitely a negative number, and it goes -1/2. Okay. All right. Okay, so we can tell what it is from looking at the graph and also looking at your function up there. Okay. All right. Okay, axis of symmetry. So remember axis of symmetry, okay, you can look at your x value, it's where, or the vertex, and it's where your graph perfectly cuts in half, okay, symmetrically, right? So we cut in half perfectly right here, okay, and the x value is -1, okay, so x equals -1. All right. Okay. All right, and then the last two, okay, domain and range. Okay, so again, domain, okay, is a set of all possible x values, okay, and we read it from looking at the graph from the left to the right, all right? Okay, so from the left to the right, so again, I'm only looking at my x values here, only looking at this horizontally, okay? So then from my left side, okay, so in my graph, do you see that it's coming, that's coming from negative, all of my negative x values, okay? So that means it starts from -infinity, and then I continue along, okay, looking at the graph, and it goes on and on and on forever to all my positive x values. So the domain of this guy is -infinity to +infinity. Okay, so again, that's always going to be your answer for the domain. Okay, it's pretty nice. Okay, and then range, you're reading it from the bottom, looking at the bottom of the graph to the top. Okay, bottom to the top. Okay, so from the bottom, it's coming from infinity because of these arrows right here. Okay, it's coming from infinity, but not just positive infinity. It's coming from -infinity. Okay, because again, you're looking at all of your y values. Okay, so it's coming from -infinity. Okay, and then if I keep reading up to the top, my graph stops right there. Okay, so it stops right there, which is where on the y-axis? 4.5. Okay, put in your bracket, because that's where it definitely stops. All right, you guys. Okay, so this is perfect. Okay, and that's my answer for number 2. All right. Okay, so let's do number 3. Okay, so number 3, this is a real-world application problem. Okay, so number 3, so keys, features, and context. So Tabitha jumps off a diving board, and her position can be described with the function. Okay, so h of t equals -16t squared plus 12t plus 4, where h of t is Tabitha's height in feet at a given time in seconds. Use the graph with to describe the key features in context. Okay, so let's say, looking at this context, so say this is Tabitha. Okay, so she jumps off of here, she reaches this maximum height right here, and then she hits the water right there. Okay, so there is our context. There's our story problem. Okay, so let's label the x and the y-axis according to the problem situation. Okay, so h of t, okay, can also represents my y values. So h of t, so that is my height. So the y-axis represents the height, okay, how high does she go when she jumps off the diving board, and the x-axis is her time, okay, her given time. How long does it take for her to jump off to the diving board to hit the water, okay? So what does this function start? So why does this function start and stop on the y and x-axis, okay? Because if you look at the domain, okay, so domain is time. It has a start and a stop because we cannot go back in time. We can't go back in time. Okay, so that's why we can't have any negative x values here. Okay, so domain in time. Okay, and then the range. Okay, same thing for range. Okay, it does not make sense to have any negative y values for range because range represents our height. Okay, you can't be -1 feet in height. It doesn't make sense. It's not possible. Okay, so that's why we have a start and a stop on the y and the x-axis. Okay, in terms of this context. Okay, so the range. Okay, so my range looking from the bottom to the top. Okay, bottom to the top. Where does it start? Okay, my graph starts right here. Okay, so at 0, so I'm putting a bracket because it definitely starts right here. It starts at 0, and then it ends right up here, which is 6.25. Okay, so that's the range of her height. Okay, she starts at a height, starts at 0 feet, and stops at 6.25 feet. Okay, so that's what this means. Okay, and then domain. Okay, domain. We're looking from the left to the right. Okay, so the left to the right, left to my right. Okay, so from the left, where do I start? From the left, I also start at 0. So I'm going to put a bracket there. So I start at 0, and then continuing on to the right, where does it stop on the x-axis? Right here, which is 1. Okay, so what that means is that, that means she starts, when she jumps off of the cliff, she starts at 0 seconds. Okay, but by the time that she hits the water, she stops at 1 second. Okay, so that means she's in the air for about 1 second. Okay, wow, not too long. All right, okay, so that is what the domain and range mean in this context. Okay. All right, okay, and then the x-intercepts in context. So the x-intercepts, okay, so where the graph crosses the x-axis, looks like it only crosses it once. Okay, so 1, 0. Okay, so 1, 0. And then the y-intercept, okay, where it crosses the x-axis is right here, 0, 4. Okay, so this just means, the y-intercept means that she starts. So again, this is where she starts. Okay, this is where she's standing on the diving board. But then she's up here in the air, and then she hits the water right there at 1 second at 0 height. Okay, so the x-intercept is where she hits the water. And then on the y-intercept, it's where she's standing on the diving board. Okay. All right. Okay. But then the vertex is a minimum or a maximum at what? Okay, so my parabola opens down, which means that I have a maximum point. Okay, a maximum at 0.375 for x value and 6.25 for y. Okay, and the vertex, what that means in this context is that the x value, remember, represents time. So that means at 0.375 seconds, she hits at maximum height of 6.25 feet. Okay. All right, you guys. Okay. So this is features of quadratic functions. If you have any questions about this, please let me know. All right. Okay, you can request me for Flex. You can come and see me after school. You can shoot me an email, and I can make accommodations for you then. Okay. All right, you guys, have a great day. Okay, and I'll see you next class.